So we're reviewing for Chapter 13, and I'm going to give you a list of all the things that you need to know, concept checklist. But to start with, let's work on this problem, and then I'll give you a bunch more that would be good ones to practice. I'll pause for a second while you process that. Find it on the sheet. It's in that little list on the board there. You will get a spreadsheet, or not a spreadsheet, a sheet full of identities that you can use on the test. Okay, so I started by getting the identity that was appropriate for this because it was the cosine, not sine, and it was add, not subtract. So I knew it was the blue one. And then I put all of the angles in from here and here. And now I just need to figure out what is cosine of 7 pi over 4. So to do that, I'm going to put my 7 pi over 4 over here. And 7 pi over 4 would be right there. That is a 1 root 2, but that's the most common mistake in circle trig. -1. If you've got a negative right there, you're making a tiny little mistake in your problem. That's for 7 pi over 4. Now for the other one, I'm going to put the other one, 2 pi over 3 over here. 2 pi over 3 would be found right about here. And so I'm going to make a triangle around that. And this is the 60. And this is the 30. So it's a 1, 2, square root of 3. That's the right angle. Most common mistake in circle trig, negatives. Okay, now if I'm going to do the cosine from 7 pi over 4 here to get this answer, cosine's adjacent over hypotenuse, 1 over root 2. I had one kid come up and ask me the question, and all she had done is right there she had put in a negative that she wasn't supposed to, and then it messes up everything. All right, next is cosine of this one, 2 pi over 3. So cosine in that one is adjacent over hypotenuse, -1/2. Minus coming down here, sine of 7 pi over 4. Sine is opposite of hypotenuse, -1 over root 2. And sine of the 2 pi over 3, which is this one. Sine in there, opposite over hypotenuse, root 3 over 2. Now, I've done a lot of these, so I can just kind of like see this, but I'm going to try to make it more clear. Those parts have to now have this subtract factored in and put that all together to get your top, because the bottom is super easy. Look at the bottom. It's just 2 root 2. So on the top, I have -1 times the 1 makes -1. And then that negative here and this negative here will cancel each other out and become positive square root of 3. And there's your answer. Raise your hand if you guys had that one right. Okay, good. Now, the next one I'm going to throw out for you to try is number 2 here. If you guys haven't got to this one, it's sine of 2 theta, where they're going to tell you about theta. Cosine of theta is equal to 9/10 in quadrant 1. So I know it's right here. And cosine is the adjacent over the hypotenuse. So it's kind of like this, where its adjacent side is 9. And its hypotenuse side is 10. And this last side I would need to figure out. I've given you a great way. I go with 81 and 100, but I got to put the 100 first because I might be subtracting these. So you square both of them. And if you're doing the biggest side, you add them. But I'm not, so I subtract them. So then that ends up being square root of 19, I think? Raise your hand if you got square root of 19. Okay, good. Then I go back to my sine of 2 theta, and I know that that's 2 sine cosine. And that's 2, and then sine of that angle. I go look over here. Sine is opposite over hypotenuse, root 19 over 10, times cosine, adjacent over hypotenuse, which is 9/10. And now I would do a little simplifying. The 2 in this 10, this is 2 times 5. The 2 cancels. And I get 9 root 19. Thank you very much.
You're welcome.
over 5 times 10 is 50, and there we go. 9 root 19 all over 50. Whew. Did anybody get that one right? All right, only a few groups. Well, a few groups. All right, so if there were struggles in here, please just help me understand where were the mistakes made. Who had trouble getting the square root of 19 part? Any groups that did not get square root of 19? Okay, and that's not the problem. Was it putting all of these in? Just somebody help me understand where you messed up. Was it the simplifying? Okay. What I think is happening is people actually had it right, but just didn't raise their hand when I said who got this right. Either that or you're not willing to tell me what you did wrong. Missed growth opportunity, I guess. All right, moving on. There are 3 proofs I wanted you to do. I am certain that this one was easy for most groups. There's always somebody who just kind of having a bad day and can't do it, but let's give people at home that are just seeing the video here a chance to try this one. So I'll pause for a second and see if you can prove that that simplifies down to 1. On this one, here's how you do it. The cosine would turn into, actually, I'd leave it as 1 over cosine. I know your instinct might be to change that to secant, but let me give you a good tip. Change everything to sine and cosine. If you can, change everything to sine and cosine. So cotangent is cosine over sine. And watch what happens. When there's everything in sine and cosine, this last one, sine, then you can see easily what can cancel. That can cancel that, and that can cancel that. And now I'm down to just 1 over 1, which is 1. So always finish your proofs like that. Okay, next one for a proof. I suggested kids try to prove that 1 over 1 plus sine. And as soon as I see that, I start thinking conjugates. You know why? Because if that was 1 squared minus sine squared, then it can change to cosine. So I'm thinking conjugates. So if you haven't already conquered this one, I'm sure there's some groups that haven't. Everybody try, now that you know it's supposed to be a conjugate, multiplying this fraction by something on the top and something on the bottom, and multiply this fraction by something on the top and something on the bottom. And when it's all done, we know it's supposed to prove out to equal -2. Can somebody read me the rest of that? Sine what? This is B over there on the board. I just can't read it.
2 sine and theta sec squared.
Secant squared. Thank you. Sine, and I gotta believe you. Secant. It's secant squared. Okay. All right. So if you don't know what a conjugate is, I'm just going to help a little bit further. It's 1 minus sine goes with 1 plus sine. And then I have to do the same thing on top. And over here, it's 1 plus sine. 1 plus sine. I'll pause for a minute while you work that out. Okay, so on the top here, you've got 1 minus sine over 1 minus sine squared, which is just begging to be changed out for something else. Sine squared is the same. 1 minus sine squared is the same as cosine squared. And this is 1 plus sine. Same denominator. So what I'm going to do is I'm going to put them together because they have the same denominator. And I'm just going to put them all into one big fraction because that you can do that when they have the common denominator, right? And that denominator was 1 minus sine squared, which I'm going to change to cosine squared. Was that too much at once? That's 1 minus sine squared, which in turn is cosine squared. And then this negative, I hope you know this, it's not just going to land on the first number it sees. It's going to get distributed to both of these. Okay? So that's -1 and negative sine theta. Okay, then this one and this -1 will cancel. They're gone. And negative sine theta and another negative sine theta makes -2 sine theta over cosine squared theta. And I'd like you to just finish it from there. You're really close. I know some groups hadn't got that far, so try to take it from here the rest of the way. Pause for a second and work that out. Okay, so I think this spot right here is what got a lot of people when you had to distribute that negative out. That really came from here, and that negative would end up distributing into both parts of that parenthesis. Okay, so now this cosine is the only thing that's out of place, and it's really 1 over cosine. So if I just can throw in an extra times 1 here, and it kind of budge the cosine over, you get to see pretty easily it's 1 over cosine. And that's right on my sheet. 1 over cosine is the same as secant. So then I can go right to -2 sine theta, and then that 1 over cosine right here is secant squared. And that's what I wanted to prove that it was equal to. There we go. Okay, and now the beast, the last one. If sine of theta plus cotangent squared theta times sine squared theta times cosecant all simplifies down to just cosecant. That's kind of cool that all of that complicated stuff can simplify down to just cosecant. I know some of you have been working on this for a bit and might have an idea. I'm sure some are even done. But who can tell me one thing that you could do that would make this simpler? Yes?
You could spread them out into sines and cosines.
All right. Let's make it all sines and cosines. I've heard of that before. Sine theta. And you might be thinking, but we want the answer in cosecant. Well, isn't cosecant just 1 over sine?
Mm-hmm.
So if we can make it all sines and cosines, I like that idea. So this cotangent would be what then, Zodi?
The cotangent would be cosine squared over sine squared.
Okay. And then the sine squared is still there. And that's already in sines and cosines. And then the cosecant.
Would be 1 over sine.
Yep. And now let's do a little simplifying in this part. Would you agree that I could cancel off
The sine squared.
the sine squareds? Yep, I can't deny it. That's just sitting there begging to be canceled. Okay, and now I've got sine plus cosine squared. I'd better write this. Now I have another way we could have done this, which I think would have been easier, but I'm going to go with this. Cosine squared over sine. We know this has to simplify down to cosecant. Yes?
You can turn the sine on the left into...
Okay, stop. I know what you're going to say, and you're right, but I want to ask kids to do it a certain way. Okay. Right now, you have 2 distinct things that need to be added together. Do you agree that if I put this over 1, you could argue that we need a common denominator to do that? Everybody, make it have a common denominator. This is one of the skills you'll have to use on the test, making common denominators. There's no problem that I don't think you can do it any other way. So was there anybody that's already done with this problem? You got it to work? All right, a few of you. Now there's another way to do this that I would have liked also, but I'll show that in a minute. So then you'd put sine and sine. And the cool part is you have a common denominator. And the other cool part is we have sine squared plus cosine squared. And what is sine squared plus cosine squared? 1 over sine theta. And then what is 1 over sine? It's cosecant. All right. So that would have totally worked. But I'm going to show you another way. Because I know that you may have to use this strategy that I'm about to show you. And therefore, I want you to have practiced and like seen it in action. Okay? Okay, so here's what I would want you to ponder. Do you see right here, just a second, that this sine and this cosecant just sitting right next to each other are just begging to cancel each other? Because cosine is 1 over sine. Okay, so if we just take that part right there and you simplify it a little bit, then we'd have cotangent squared times, well, this sine, and this being 1 over sine, I think if I just show that much work, you'll see, oh yeah, then one of the sines would cancel, and I'll have sine theta left over. Now what's good about that? Right here, I want you to think, right there, what should you do next then? Give it just a second more. I want to let people think. What do you think, sir? So I say it a little different way. If you can factor it, you should. Do you get how they both have a sine in them? Look, right here. They both have a sine. And this is the 43rd time where a bunch of really smart kids are stumped. One figured it out. Nice job. But you factor the sine out, and I want everybody to see why that helps. See what you get left. Talk to your partner. You should be able to get this down. That's awesome. I think he saw it. To factor out the sine, you've got to be able to do this. Do you get that when you divide this both by sine, that's what you're really doing when you're factoring out? And this becomes 1 plus, and those cancel each other out, cotangent. And I've been telling you, the one with the coat is what? Cozy. And if you can't get that to the end, then there's not much hope for you tomorrow. Even at the end here, if you just like, well, get everything down to sines and cosines, be a thought. If I make this cosecant into 1 over sine squared, and then a sine, and then the sines will cancel, and it's 1 over sine. And what is 1 over sine? Cosecant. And that's what we wanted to prove it would do. Bring that all the way down here. Cosecant. Okay. Did you have to do it that way? No, I showed you a different way first. So, that's a bunch of problems. Is it everything? No. These are all the concepts. It's a concept list. You got to know how to do conjugates. Let me just go through that list with you because these are all important to do. We did conjugates. That's the like 1 plus sign goes with 1 minus sign. You got to be able to factor things out. We just did that. Changing into terms of sine and cosine. We talked about that and did it. Look to basically make sure that the things you want to come out on the other side, change it into terms of that. So if you have cosecants in your answer, we'll try to get cosecants to show up. And doing common denominators, which we practiced once too. And of course, all of these identities like reciprocals, we did the Pythagorean, one with the code is cozy, and the double angles, we practiced those. So we've practiced a lot of this. And careful with the negatives. Draw your circles whenever you're doing like the circle trig stuff. And don't forget to simplify your answers. Good enough. So they have a couple more identities, but I'm going to actually make those have a backseat to the ones that are on the worksheet. So there is a worksheet for today. And I am assigning your choice of 4. Pick any 4 you want. And there's a Dropbox. Dropbox it. Because I like to have a little bit of formative stuff now and then. And I don't want it to always be quizzes. Sometimes I want it to actually be homework. Okay, so I'm giving you 4 problems of homework. Just 4. I could have just said do the whole sheet, but I'd rather have spent time like we did in class, kind of doing a bunch of problems together, than to just give you a bigger assignment and no help. All right, so 4 problems of your choice. If you're really smart, you'll do problems that scare you. If you already see how to do a problem, it's kind of fun, but it's not going to make you learn. You'll just reinforce what you already know. Do the ones that scare you out of the set. All right, and that's all I have for you for the video for today.